Okay, so this video we're going to do applications of proportions with similar triangles. Similar triangles, the way we set up the equations with similar triangles is as a proportion. Okay, so definition: similar triangles are triangles where each angle in one triangle has the same measure as an angle in the other triangle. So the short and sloppy way would be to say the three angles are the same. The angles are the same, would be even sloppier. But this is precisely what's meant, is you can match up each angle in one with one angle in the other. And you can do that with all three of them. So an important fact is that similar triangles are proportional. That's like a theorem. This means the ratios of the lengths of corresponding sides are equal. That's what it means. So if I take any two sides and I take their ratios, they're equal, which gives us a proportion. So here's an example. This is the way, sometimes I labeled the angles with Greek letters, alpha, beta, gamma. Those are the first three letters of the Greek alphabet. They don't have a C. Alpha, beta, gamma. And usually we'll label the opposite sides with lowercase letters that match. So opposite alpha is A, opposite beta is B, and opposite gamma is C. The letter C actually comes from Latin, because they had this letter that sometimes sounded like a K and sometimes sounded like a S. So they made up a letter C for it. Anyway, and I used capital letters on the second one because I made it a little bit larger than the first one. So these are the similar triangles. You can tell they're similar because the gamma, they both have a gamma angle. That is gamma is the measure of the angle, right? It's how many degrees it is. And then beta, the two betas are the same angle, and the two alphas are the same angle. And then the A side is the side opposite alpha, so it corresponds to the little a side. The capital A corresponds to the little a. The capital B side corresponds to the little b side. They're not the same, but these ratios of these sides will be proportional. So what does that mean? It means A over A equals B over B equals C over C. And you can put the other one on top as well. Little a over big A, little b over big B. I just tend to put the bigger numbers on top. Usually the arithmetic turns out easier that way. Not always, but usually. And capital C over little c. Now that's actually three different equations written in one. So don't get confused. You never write all three of them together when you're working out a problem. You would write these first two, right? Take the ratio of the A sides equals the ratio of the B sides, right? Or the ratio of the B sides equals the ratio of the C sides. I'm covering things with my hand here, my pointy hand. Or the ratio of the A sides equal the ratio of the C sides. Okay? So there's three different equations. And so you just need four sides that correspond to make these ratios and make it into a proportion. So I just wrote that down so you have it in your notes. So these are common triangles. There's two common triangles, and they're just used for a lot of examples. They do come up in real life fairly often, but they're used in math mostly because they're just some triangles that we can expect people to know the ratios of the sides. So this is one. This is a 30, 60, 90 degree triangle. So it's a right triangle because it has 90 degrees. Right? And the other two angles, well, you can see how the angles change in size. 30 is the smallest, then you double it, you get 60, and you triple it, and you get 90. So it's kind of a nice triangle. And this is what I call a template. It's a template size. With those angles, you can have a triangle of any size, right? But we make it so that the smallest side is length 1. The longest side is length 2. The longest side is always the hypotenuse. The largest side is always opposite the largest angle. The smallest side is always opposite the smallest angle. That's a theorem in geometry, okay? So the smallest side is 30 degrees, so the smallest length side is 1, right? The largest angle is 90 degrees, and so the hypotenuse is the largest one. And we'll call that, and that happens to be twice as big. So that's 2. And then the third side, the second leg, is square root of 3. And you just have to remember square root of 3. But maybe you can remember that because these numbers, these angles are all multiples of 3, right? Actually, all multiples of 30, but they're multiples of 3. So there's a 3 in there somewhere. It's just a way to remember, you know? It's a square root. So the smallest one is a 1, the largest one's a 2, and the square root of 3 is in between 1 and 2. How do I know that? Square root of 3 is between square root of 1 and square root of 4. Because 3 is between 1 and 4. And square root of 1 is 1, and square root of 4 is 2. So square root of 3 is between them. Just in case you... Or you could put it in your calculator and see that it's between them that way too. But that's a template size. Now some people learn this, before I go on, I should mention. Some people learn this slightly differently. They'll learn this as their template size would be 1/2, 1, and square root of 3 over 2. If you've seen that before and you're used to that, that's fine. Personally, I prefer for my template size to not have any fractions. So this is the best one as far as I'm concerned. But the other works as well. You could just say, oh, my size is half as big as his. My triangle's half as big. So I use, for a template, I use 1/2, 1, and square root of 3 over 2. What do I mean by template? I mean, if I have any 30, 60, 90 degree triangle, and I know what the length of one of the sides is, I can use similar triangles to find the lengths of the other two, as long as I remember this one. So I use this one to get to the length of the sides of any other 30, 60, 90 degree triangle. I have to remember one of them, so I remember that one. Okay, and then the other one that's a common triangle is a 45, 45, 90 degree triangle. Right. I guess these are the two easiest as far as angles go, because this one, this angle is half this 90. Right, for right triangles, these are the easiest ones, because this 45 is half of 90, and this 30 is a third of 90. So the next one would be a fourth of 90, which the numbers start getting a little bit weird because 4 doesn't divide 90 nicely. Right, so that's probably why they ended up choosing these. Plus the numbers here come out fairly decent. There's a square root in both of them. This has a 1 and a 1 and a square root of 2. And again, you might have learned this as square root of 2 over 2, 1 over 2, and 1 over 2. You might ask yourself, why the 1 over 2 and 1 over 2? Or you might have learned this as 1, square root of 2 over 2, square root of 2 over 2, which just seems like a whole lot of work to me. There's no, they're doing that for trigonometry reasons, but it's not even a good reason for trigonometry. So it's just kind of silly. 1, 1, square root of 2. And if you forget the square root of 2, you can figure it out using Pythagorean theorem. Square root of 1 squared plus 1 squared would be the square root of 2 thing. Anyway, those two you need to know. Make sure that you find a way to know them. Look for patterns, make up a way to remember them if one of the ways I told you doesn't work for you. Okay, so we will assume that you know those two. And by we, I mean me and any other person you take math with.